For decades, interacting with software has basically been um, like using a vending machine.
Right, very transactional.
Yeah, exactly. You push a very specific button, you wait a second, and the machine drops a highly predictable prepackaged result right into the tray. I mean, it's entirely passive. The machine doesn't care if you're actually hungry or, if you meant to press a different button. It just blindly executes a direct command.
And it requires the human to do, well, basically all the prerequisite thinking. You have to know exactly what snack you want, you have to know what row it's in, and you have to provide the exact right currency.
Right. But imagine if you walked up to that same vending machine and instead of pushing a button, you just said, hey, I have a team coming over for a brainstorming session at 2 p.m. Make sure everyone is fed.
Oh, wow.
And suddenly the machine grows legs,
Yeah.
walks to the grocery store, negotiates bulk pricing on snacks, checks everyone's calendar for dietary restrictions, and, stocks the conference room before anyone even arrives.
That is quite the visual.
It is. But that leap from a passive machine waiting for a prompt to an autonomous, problem-solving entity, that is exactly the transition the entire tech industry is going through right now.
Yeah, it really is the defining shift of our current time. We are moving into what's being called the agentic era. I mean, we're leaving behind those AI models that just, generate text or write code in an isolated little chat window. Instead, we are entering a world of autonomous, tool-using agents that can actually reason, plan, and execute multi-step workflows in the background entirely on your behalf.
And today, we're going to explore exactly how the entire technology stack is being ripped out and rewritten to support these new digital workers. Our guide for this deep dive into the subject is a massive stack of intelligence, random technical news you can absolutely use, curated from the desk of Andrew Kagan.
It's a great roundup this week.
It really is. We are going to look at how this shift is impacting everything, from the raw, physical hardware running in the cloud, all the way up to how you, the human, actually prove your skills in a world where AI writes the code.
Okay, let's unpack this because you can't have brilliant agents running on sluggish infrastructure, right? The physical hardware has to evolve first.
Absolutely. The agents are really only as capable as the foundation they run on, and these autonomous workflows are incredibly compute intensive, which is exactly why we're seeing Azure roll out the new Cobalt 200 ARM-based virtual machines.
The Cobalt 200s, right?
Yeah. And this is a big deal because ARM architecture fundamentally changes the power-to-performance ratio. We're looking at, a 50% performance improvement over the previous Cobalt 100 generation, but crucially without requiring some massive spike in energy consumption.
Which is huge for data centers right now.
Yeah.
And they feature this really deep integration with Canonical and Ubuntu for Linux workloads.
Which makes total sense, because if you're spinning up massive clusters to run these AI pipelines, Linux is basically the undeniable backbone. But what I found really interesting in Kagan's notes is that Microsoft isn't just, upgrading the destination. They're actually using AI to pave the road to get there.
Oh, you're talking about the Copilot migration agent.
Yes, exactly. They've introduced the Azure Copilot migration agent, which basically analyzes and simplifies moving legacy on-prem file shares into this new cloud environment. It's essentially AI acting as the moving company to build the home for future AI.
That's a really great way to frame it. But, powerful compute is really only half of the infrastructure equation. The other half is the data layer itself.
Right, the plumbing.
Exactly. If an agent is making split-second decisions, it simply cannot wait for a slow database query. And that's why Azure Horizon DB for PostgreSQL is such a massive leap forward here.
Okay, tell me about that.
Well, first, it achieves zero cloud lag, meaning the literal day a new major version of Postgres drops, it is instantly available in Azure. But the true mechanical advantage here, the thing that changes the game, is that they have completely decoupled the compute layer from the storage layer.
Okay, let's break that down for a second, because decoupling compute and storage sounds like very deep back-end jargon. Why does that actually matter to an agent trying to complete a task for you?
So think about a traditional database where the processing power, the compute, and the hard drives, the storage, are physically tied together in the exact same box.
Right, like a standard desktop computer, basically.
Exactly. If you have a sudden spike in AI queries, you have to upgrade that whole box, which takes time and obviously causes latency. By decoupling them, Azure pushes all that heavy input and output traffic to a highly optimized shared storage platform.
Oh, I see.
The result is sub 1 millisecond commit latency. The agent gets its answer instantly, no matter how much data is being processed in the background.
And that speed is amplified by how it handles vector searches, right?
Yeah.
Which is basically the native language of AI.
Yeah, exactly.
Because HorizonDB natively supports Microsoft's Discan technology. And the mechanics of this are just wild. It uses a quantized vector graph in memory.
Right, which sounds complicated, but
Yeah. To put that simply, imagine you are in a massive, sprawling library. A quantized vector graph is, it's like a tiny compressed digital index card sitting on your desk. It's a low-res map that tells you exactly which aisle to walk down.
that's a perfect analogy.
And once you're in the right aisle, you pull the actual book off the shelf, which is the high-res, full-precision graph stored on the actual disk. It basically saves the system from having to load the entire physical library into RAM just to find one single paragraph.
That is precisely how it works. And to make it even more efficient, HorizonDB actually has built-in AI pipelines. So when new unstructured data hits the database, this pipeline automatically chunks it, creates those vector embeddings, and processes it in the background.
It's like having a dedicated sous chef in the kitchen.
Ex
By the time the master chef, your AI application, in this case, is ready to cook, all the ingredients are already chopped, measured, and prepped.
Right.
But, even with lightning-fast hardware and perfectly prepped data, there's still a massive blind spot here. And this is something I think a lot of companies get wrong.
Like a context problem.
Yes, an LLM trained on the public internet might be incredibly smart, but it has zero context about your specific business. I mean, if I ask a generic model to, calculate our revenue, it might just pull standard gross income.
Right, standard definitions.
But my specific company might define revenue as annual recurring revenue minus customer churn. If the agent doesn't know that specific nuance, it's going to completely hallucinate my financials.
And obviously, nobody wants to teach a new digital employee how their company works from scratch every single morning. That is the exact friction point Microsoft Fabric is targeting right now.
Okay.
They've introduced the Rayfin SDK, which basically turns user prompts into production-ready backends. But more importantly, they're leveraging Fabric IQ's ontologies.
An ontology being the literal map of your business logic.
Exactly. It explicitly defines your specific business entities, relationships, rules, and actions. It tells the agent, hey, here's how this specific company defines revenue, and here is exactly where that data lives.
That's huge.
And what's fascinating here is how this logic is becoming reusable. With DAX user-defined functions in Power BI, data engineering teams can write this complex business logic once and then just embed it across all their semantic models.
So when an autonomous agent is asked to analyze a drop in sales, it isn't guessing. It is pulling from a deeply trusted, predefined set of mathematical rules.
Precisely.
Okay, so the plumbing is incredibly fast, the data is prepped, and the business context is strictly defined. That gives us the perfect foundation. But what exactly is running on top of this? We need to talk about the brains of these agents.
The models.
Yeah. Andrew Kagan's industry updates show an absolute explosion in the sheer volume of models hitting the Microsoft Foundry. I mean, we are completely moving away from the idea that one giant monolithic model is going to do everything.
Right. The strategy has definitely shifted. It's now about using an ensemble of specialized models, picking the exact right brain for the specific task at hand.
Just looking at the industry news from the newsletter, you have the new MAI family from Microsoft. Their flagship reasoning model, MAI Thinking 1, actually beat Sonnet 4.6 in blind human side-by-side evaluations.
Which is a huge milestone.
Yeah. And then you have DeepSeek V4 entering the fray. You have Grok 4.3, which is highly tuned for advanced domain-specific workloads. And you have Fireworks AI integrating models like Kimi 2.6, which specializes in extremely long-horizon reasoning.
But, the integration that really stands out to me is Anthropic's Claude Opus 4.8 hitting Microsoft 365 Copilot.
Oh, yeah.
Because this isn't just about raw intelligence, it's about unit economics. This week's intelligence notes that Opus 4.8 offers a 61% cheaper token cost when reasoning over dense, unstructured content like massive PDFs or complex technical diagrams.
Which is absolutely critical. I mean, if you have an agent running in an infinite loop in the background, constantly reading every email and document that comes across your desk, token cost becomes your biggest bottleneck really fast.
Exactly.
You need a model that is smart but economically sustainable. But, cheap tokens don't mean anything if the user experience is still stuck in a clunky little side panel chat box.
Right.
That brings us to how we actually interact with this intelligence. Because the UI in Microsoft 365 Copilot is completely transforming.
It really is. We are seeing a very deliberate move away from the generic chat interface. Instead, these capability-focused agents are moving directly onto the canvas in Word, Excel, and PowerPoint.
So they're right there in the document with you.
Exactly. They are transitioning from being a passive chatbot that you have to command to an active contextual editing partner that lives directly inside the workspace.
But, I mean, an agent acting on a canvas is still waiting for you to open the document in the first place, right? The real leap happens when the agent stops waiting for you at all. And that is the shift toward autopilots, specifically a new category Microsoft is calling Scout.
Yes, the Scout agents.
These are always-on personal agents that live in the background, understand your working habits across all your apps, and take action without needing a daily prompt.
They are essentially proactive delegates. They sort through the noise, they prep your meetings, and they flag critical items while you are focused on other things.
Okay, I have to stop here and push back on this for a second, because giving an AI the keys to act on my behalf while I'm asleep sounds like an absolute compliance nightmare.
It's definitely a concern.
Right, like who takes the blame if my Scout misinterprets an email and accidentally forwards highly sensitive financial data to an external vendor? How do we actually stop this autonomous entity from going rogue?
That is the exact panic enterprise IT teams are feeling right now, and it's exactly why the architecture of Scout is so tightly bound to identity. Scout does not operate on some shared anonymous service account. It operates under your specific entry ID. It fundamentally inherits your exact permissions, your credentials, and your access controls.
Ah, I see.
So if you, the human, do not have clearance to view that financial document, your autopilot physically cannot see it either.
So it's literally wearing my corporate ID badge.
Precisely. Every single action it takes is attributable to a known actor in the directory. And, to combat the hallucination risk, these agents are grounded by new enterprise APIs called WorkIQ and Microsoft WebIQ.
And WorkIQ just went generally available, right?
Yes, it did. These APIs tether the agent to real-time enterprise data. Kagan's notes actually highlight companies like SLB and Miro who are already leveraging WorkIQ to unify their internal knowledge. So things like meeting transcripts, subsurface architectural data, design canvases.
So the agents are making decisions based on the exact same verified reality that the human workers are operating in. All right, so we have these brilliant, economically viable models, and we have autopilots handling our workflows securely. But someone actually has to build and stitch these systems together, right?
Well,
without creating some kind of digital Frankenstein.
right.
How are developers surviving this shift? Because building an autonomous agent is fundamentally different from building a traditional web app.
It requires an entirely new approach to software engineering, honestly. What we are seeing in the DevOps space is a major shift toward a two-layer architecture.
Two-layer, okay.
Yeah. You have to separate the coding agent, which is the AI system that actually writes the code and scaffolds the app, from the runtime agent, which is the final product the end user interacts with.
Here is where the mechanics get really interesting. Because to make that two-layer system actually safe, you use something called a skill file.
Yes, skill files are crucial here.
If you just open a standard Copilot and say, hey, build me a secure inventory app, it's probably going to hallucinate a generic structure.
Yeah.
But a skill file acts completely differently.
Yeah.
It's less like giving a builder a blueprint and more like programming the physics engine in a video game.
That's a great way to think about it.
It defines the literal laws of gravity for your code base.
Exactly. The skill file explicitly restricts the coding agent. It dictates your specific framework idioms, your required data loaders, and crucially, your anti-patterns, the things it absolutely cannot do.
Right. Kagan uses the example of a fictional e-commerce company called ZavaShop.
Yeah.
Their skill file tells the AI that it is physically impossible to hard-code model names and dictates exactly how to handle API errors. So the coding agent has to read this physics engine first.
Right.
And the code it spits out doesn't look like generic AI slop. It looks like it was meticulously handcrafted by your own senior tech lead. It is literally an agent building an agent safely.
And to give developers a safe place to test these complex agent-on-agent interactions, we are seeing the rollout of Windows 365 for agents and Windows 365 Flex.
Right, because testing is a whole different beast now.
It is. Testing an autonomous system requires a perfectly consistent environment. And Windows 365 Flex solves this with a snapshot-based reset.
How does that work?
Well, once a developer finishes running a test scenario on a shared cloud PC, the system automatically flushes the environment and reverts back to a perfectly clean, known state for the next test. It entirely removes the friction of environmental drift.
Oh, that's brilliant. But this isn't just a playground for pro developers writing command line code.
Not at all.
The low-code builders are moving just as fast. We're seeing a massive rise in vibe coding with tools like CodeApp.js. And this isn't just like dragging and dropping UI elements.
Right, it's way beyond that.
With vibe coding, a citizen developer just describes the intent of the application, like saying, I need a dashboard that tracks inventory and flags items below 10 units. The AI understands the vibe and simultaneously scaffolds the backend database, the API connections, and the responsive front end.
And that level of automation is exactly why the general availability of Power Pages agentic coding is so vital right now.
Because it adds some guardrails.
Exactly. It brings much-needed enterprise rigor to this low-code explosion. It now natively includes application lifecycle management, ALM, and Power Platform pipelines.
Right.
So when a business user scaffolds a portal with natural language, the system automatically handles the secure promotion of that code from a development environment into testing and finally into production, complete with web application firewalls.
Speaking of portals, Dynamics 365 portal templates just got a massive modernization upgrade as well, didn't they?
They did. They now default to the Enhanced Data Model and Bootstrap 5.
Which means what, exactly, for the end user?
The mechanics here mean these portals provision significantly faster, they are natively responsive across mobile devices right out of the box, and they hook seamlessly into those modern application lifecycles we just talked about.
Okay, but if we have citizen developers scaffolding apps with vibe coding and autonomous agents writing their own back-end logic and autopilots executing workflows while we sleep, how do you stop an agent from accidentally granting public access to a sensitive database?
Yeah, that's the big question.
I mean, the traditional network firewall is basically a screen door at this point. How do you lock down an entity that is already inside the network?
That is probably the most terrifying and exciting part of this research. The security paradigm has completely flipped. In the agentic era, identity is the new perimeter.
Identity, right.
Because human workers, AI agents, and third-party APIs are all interacting so fluidly now, security teams are deploying a unified identity inventory. This system correlates your on-prem Active Directory, your cloud Entra ID, and third-party service accounts into one single unified identity.
Which allows the system to establish a unified risk score.
Exactly. So if an AI agent that usually just, schedules meetings suddenly tries to query a massive payroll database it has never touched before, that risk score spikes instantly. Conditional access policies detect that lateral movement in milliseconds and sever the connection.
And the defense mechanisms themselves are actually becoming agentic. We have to talk about MDASH, the Microsoft Security Multi-Model Agentic Scanning Harness. This genuinely blew my mind.
If we connect this to the bigger picture, it is a perfect example of how AI-scaled threats require AI-scaled defense. MDASH is an ensemble security system. It doesn't rely on one single model to scan for bugs.
Right.
It orchestrates over 100 specialized AI agents that actively debate, investigate, and attempt to prove vulnerabilities in code.
And it actually found 0 days. The notes reveal that MDASH discovered critical vulnerabilities in the Windows kernel TCP/IP stack and the IKAV2 service. And it recently achieved a 96.55% score in CyberGym evaluations. It proves that a team of AI security agents aggressively stress testing each other can find highly complex exploitable flaws that human researchers or, traditional rigid scanning tools simply miss.
But securing the code is really only one piece of the puzzle. You also have to govern how these agents behave in the wild. We are seeing a huge spike in shadow AI.
Oh, where employees just run unmanaged models?
Exactly. Local AI agents running directly on their laptops to help with their daily tasks. To rein this in, IT departments are deploying the Agent 365 SDK and the new Agent Registry, which actively scans and discovers these unmanaged local models running in the background.
And to protect the data itself, Microsoft Purview is stepping in with runtime data loss prevention. It acts as an active interceptor.
Right.
Let's say a local agent tries to send highly sensitive financial data into a prompt directed at a public LLM. Purview detects the nature of the data and physically blocks the transmission before the prompt ever leaves your secure environment.
And because enterprise environments now have dozens of different models from different vendors constantly talking to each other, Azure API Management has introduced the Unified Model API.
What does that do?
It acts as a universal translator. Your application just speaks one standard language, and the API management layer seamlessly translates the call whether the backend is an OpenAI model, an Anthropic model, or a Google Vertex model.
Oh, that's incredibly useful.
And crucially, it applies universal content safety policies across all of them, especially for agent-to-agent or A2A traffic.
Which perfectly sets up our final question for today. If the agents are writing the code and other agents are securing the code and A2A APIs are allowing them to negotiate with each other,
Yeah.
what is the human actually supposed to do?
Right, where do we fit in?
The entire tech stack has radically changed. How do we stay relevant? And how do we prove our worth?
The way the industry measures expertise is fundamentally shifting. Microsoft is introducing pro badges, and they are starting with GitHub Copilot.
Yeah, and these are a massive departure from traditional certifications. It's not a multiple choice exam where you just memorize flashcards for an afternoon.
No, not at all.
Pro badges validate actual real-world skills demonstrated through your daily work environment. It's the difference between showing an employer a driver's permit you got by passing a written test versus handing them the keys to a high-performance car you just built from scratch. It is a verified portfolio of successful projects.
And we are seeing a push for highly interactive learning formats, too, like the upcoming AI Skills Fest and the Agents Lead Hackathon, where developers actually compete to deploy the most effective autonomous agents.
That sounds awesome.
It is, but there is a very critical caveat here that we really cannot ignore. While learning prompt engineering and agent orchestration is the flashy new thing, deep foundational IT skills are actually more critical today than they were 5 years ago.
Wait, I have to challenge that. If the AI is literally writing the back-end logic and managing the infrastructure, shouldn't we just focus purely on how to communicate with the AI? Why do I need to know how the plumbing works if the AI is the plumber?
Because if you don't understand the foundational mechanics of the plumbing, you are just going to use AI to automate your bad habits at a massive scale.
Oh, wow, okay.
Let's look at Docker, for example. Understanding containerization and environment reproducibility is absolutely vital. If you don't understand Docker, your AI agent is going to generate brilliant code that runs perfectly in its isolated sandbox, but completely shatters the moment you deploy it to production.
Oh, I see.
You need foundational container knowledge to permanently kill the excuse of, well, the AI said it worked on my machine.
Ah, right. If the physics engine we talked about earlier is flawed, the AI will just build a fundamentally broken house really, really fast.
Exactly. The AI relies entirely on the guardrails you build. The same logic applies to endpoint management. This week's intelligence mentions Microsoft Intune. There are roughly 15,000 different settings in the Intune catalog.
That is a lot of levers to pull.
Right. An AI autopilot can absolutely help you navigate that massive list, but you still need the foundational human knowledge to know why you must enforce basic compliance policies like BitLocker encryption or secure boot across your fleet. The AI can pull the levers, but you have to know which levers actually matter.
That completely flips the script on how we need to approach learning right now.
Oh,
Okay, we have covered a staggering amount of ground today. We started at the absolute bedrock with the power efficiency of Azure Cobalt 200 VMs and the sub-millisecond decoupled latency of Horizon DB.
yeah, the foundation.
And then we explored how Fabric IQ gives our agents crucial business context and how the token economics of Claude Opus 4.8 makes continuous reasoning viable. We looked at how skill blueprints forced AI to write safe code, how MDASH uses an army of agents to secure our networks, and why foundational skills are the only way to stop AI from automating our mistakes.
It's a completely new landscape.
It is. So what does this all mean for you? It means the agentic era isn't just coming. It's actively rewriting the rules of the internet. But the tools to manage this massive complexity, from agent registries hunting down shadow AI to Purview DLP intercepting prompts, are being built simultaneously to manage the chaos on your behalf.
It's an incredibly empowering time to be building software. But as we wrap up, I want to leave you with one final thought to mull over. We touched briefly on the rise of A2A agent-to-agent APIs.
Right.
We are rapidly approaching a point where your personal autopilot can securely negotiate complex project timelines, resource allocations, and budget approvals with your coworkers' autopilot. And they can do it at absolute machine speed.
Right, they can settle a week's worth of back-and-forth emails in a few milliseconds.
Exactly. So if the machines can debate, plan, and execute that quickly, it raises a fascinating question about the future of work. Will the biggest bottleneck in enterprise productivity no longer be the technology itself?
What do you mean?
Well, will the bottleneck actually become the human latency? I mean, the hours or days it takes for us to simply read, comprehend, and approve the decisions our agents have already successfully negotiated.
Wow. Are we about to become the dial-up connection in our own workflows? That is a wild thought to end on, from pushing buttons on a vending machine to being outpaced by it. Thank you so much for joining us on this deep dive into Andrew Kagan's intelligence. Keep exploring, keep learning, and we will catch you next time.